G'day guys, it's Kelvin, Coaching Company New Zealand. Today we're going to talk about porting, polishing of cylinder heads. I happen to have here a set of cylinder heads that have been professionally ported by a engine builder here in New Zealand. You can see they've tidied up the chambers a little bit. These have been CC'd, so we've checked the combustion chamber size. It's fitted with a 9:1 pistons, forged pistons. It's in a UCF 20 block, so Gen 2 block with the rods and pistons. Getting supercharged. Now with a 1mm head gasket, it equals 9:1 compression. So with the 1mm head gasket, it will be 9:1 compression. If it's got a 1.3 head gasket, then it probably needs about 0.3 taken off the block to give it 9:1 again. Drops to about 8.6, which is a little bit low. And that's part of the porting process and the checking, not just flow numbers, the CSA of the ports, angles and the tapering of the ports. So all that comes into the job, but also checking the compression ratio or the expected compression ratio from the finished job. The individual port, you can't see it too much, but you'll see that it isn't mirror finish. It's got a little bit of a surface on it, a little bit of roughened surface, but not too rough. And the bit that they make the biggest difference on these ports is down in there, right down by the valves and in the angle. This bit here for most jobs, and this particular job, is actually as big as you'd want it to be, if not too big. So you get the bits down in here that really make the difference. That's where you get your flow out of them. The exhaust ports are just being tidied a little bit, and they've got a little bit more of a finish on them. Slightly different to the inlet to the exhaust. And I've seen lots of comments of guys with the porting, again, on different styles and different ideas behind porting. Some guys get very fixated on the flow numbers. Some guys get very fixated on the CSA, critical surface area. It's really important on these heads, and we'll talk about it more in another video when I'm going to port some heads. But ensuring that where it changes from big to small, that it isn't a rapid change. You'll get better gains with a gradual angle through there. Ideally you wouldn't change it, it'd be the same flow rate through the cylinder head, but we know that isn't always possible. And of course there's a valve in the way. That's the restriction. These particular heads haven't had the bigger valves fitted for the job that we're going to be doing with the supercharger. It wasn't seen to be worthwhile for the amount of expense we were going to spend on that. Now coupled with that cylinder head is going to be some Kelford cams. And to ensure that we get the most out of those cams, we've got these vernier cam gears on the front. And they're a neat little bit of kit set up. These have got to be torqued to spec correctly and allow the installer to dial those cams in 100%. And these ones are kind of special because you'll see here we've got another set of vernier cam gears in the middle of the cam to allow both the inlet with those ones and the exhaust cams to be dialed in correctly. So these are a set of Kelford cams, a set of SC supercharger cams, suitable for this particular job. As part of the cylinder head job, of course, all the shims were set. We've stuck with shim over buckets. Again, supercharged, we don't have to rev it really hard to make power, so there's not much chance of the buckets or the shims spitting out. Kelford maintain the surface angle or the radius on the cams too. A couple of things to note: you've got to check that it's got the bungs in them. There's fittings in the end, you've got to check that they are in there. I'm really looking forward to seeing this job up and running. I've been supplying some technical knowledge, and then these cylinder heads and parts like cam belts and water pumps and that sort of stuff. It's in a UCF 20 Celsius here in New Zealand. It's been manual swapped, so it's got an R154, which are easily available here in New Zealand. with these heads on that engine, rebuilt bottom end, got some ARP stuff of course. It should be a real beast. It should be a really exciting car to drive. It will be getting an aftermarket ECU as well. There's another guy doing that. So that should give it some good reliability. Pretty much, if we go boosted over here, it's very uncommon for us to use the stock ECU. We pretty much throw them away. Go to an aftermarket to really maximise stuff, especially when we've got cams, ported heads, and all the other stuff, changes in compression ratios. Too much time stuffing around the stock ECU for that, so we'll go straight to the aftermarket. Now, I don't normally talk about cost, but I'm going to today. This particular package with the cam gears, ported heads, the whole lot is around about 12,000 New Zealand dollars. Okay. Professionally ported heads, the vernier gears, the customer had already bought the camshafts. Oh, and there's some valve springs too. Some valve springs suitable for the supercharger. Of course, the valves were cut as well. There was some stuff that I'm not allowed to talk about too much on the back of the valves. It's kind of that performance shop's thing, and that's also why I can't talk too much about what's going on in those ports, because that's their thing. They're okay to do a little video like this, show a little bit, but if you get right into what they've done in that head, what they've done with their back cut on their valves and their profiling of their valve seats, that's something that they want to keep for themselves. And hey, good on, I'm not going to argue that. Now guys, we'll talk about what gains we're going to get. This engine was naturally aspirated. It's going to be boosted, of course, so straight away, theoretically that doubles the horsepower. Well, hold up, I forgot to mention something in there. And you see I've changed shirts, but it's because I'm editing the video and I've realized that I didn't say that I'm doubling the boost pressure. Okay, so I'm going from naturally aspirated to 1 bar of boost going into that engine. Okay, I saw it further on in the video, but I want to put it in now so people don't go, hey, you were talking this stuff and it wasn't right. So we're trying to keep the information correct here. Right, back to the video. 1 bar boost, less the parasitic loss of the supercharger. So we're going to take a 256 horsepower engine, double it, it's about 500 horsepower at the engine. Then we take off some parasitic loss, we might get like 450, and then we add some camshafts and some ported heads, and that's going to climb it as well. But of course that's applied to the first atmosphere of boost that's going into the engine. So this stuff, this air pressure, atmosphere, that is pushing the air into this engine. It pushes it into the supercharger, and then the supercharger then compounds that and pushes it into the engine. But the air going into the supercharger is pushed in. Guys will argue that it's sucked in. They're wrong. Pressure goes from high pressure to low pressure. We use the engine to create a low pressure zone, allowing the higher pressure, which in this case is the atmosphere, to push it into the engine. And when we talk about modifying the engine, we're actually modifying the naturally aspirated engine, and then we're using the compounding of the extra atmospheres of boost, or the gauge boost pressure, to work out where we end up as all the final figure. For example, if we take this 256 horsepower engine naturally aspirated and we make it a 300 horsepower engine. Yeah, I'm inside now. Again, I'm talking by adding another atmospheric boost. Okay, so that 14 psi. So when we talk about doubling it, so I'm not only doubling that airflow, doubling the boost pressure. Okay, boost of course being a measure of restriction. So that isn't quite the correct terms, but it simplifies it in this point in time. Okay, so 1 atmosphere, normal naturally aspirated, 14.7. Second atmosphere being 14.7 psi of boost pressure. We then apply the double it, less the parasitic loss. So that's of course compensating for cams and heads. Makes it 600, less parasitic loss of 50. We're at 550. And that's some really basic theory behind modifying engines that a lot of guys still don't get, okay? And they still don't understand that the air is pushed into the engine by the atmosphere. If they did, it would help a lot, and then we understand how the stuff works better to getting better results. So anyway, I'm going to pack these up, get them back ready for the customer to pick up and take away. He's going to install them, and hopefully one day he'll come down for a drive and we'll see these cylinder heads in action on the vehicle, and we'll get to go for a drive in it. I hope that happens pretty soon too, because I'm kind of looking forward to this. So what I didn't mention is this customer's goals is 400 horsepower at the wheels. Nice, reliable 400 horsepower. He's got forged rods, he's got forged pistons, he's got ported cylinder heads that are worth a whole lot of money. And this is what he wants to do, okay? So when we look at this, don't take it from, hey, I don't want to spend that much money to make that power. He could have got an early model big rod engine with some pistons and put the supercharger on and pump the boost in. But he's building a car that he wants to build. And he wants to do it on about half a bar of boost. Okay? So let's work out 400 horsepower at the wheels. Some driveline losses. It's a manual. So maybe we're going to go with 10 to 15% driveline loss. So we probably need about, or 450, give it just over 10% would be 400 at the wheel, so 450 engine horsepower. So he needs to make an engine that makes about 300 horsepower NA. We add half a bar of boost, so 0.5 multiplication, so 300 to, and half of that is 150, 450. So I think he's actually going to be a little bit surprised when he gets to the other end with the actual power levels that he's got. The supercharger is a good supercharger and it is intercooled. So I wouldn't be surprised if he actually exceeds his power goals very, very quickly, because you can see that with the parts that he's put into it. It should do that power level excessively easily. And I suspect it's actually going to have a big, long torque curve as well, which is just going to really tear tyres to pieces. It's going to be fantastic. And that's the other thing, that it's actually the torque that makes these things fast as well. So when we look at those and the stuff that he's done, it's going to be a real monster of a car. And it's a road car. So it's going to be a heap of fun to drive. Righto. Now, when we're doing these calculations, there's a couple of little caveats. It's a big word for the day, but it's a big meaning word. What it means when we're doing these calculations is that all other conditions must remain ideal. So that means you have to have sufficient fuel. But guess what? If you double the horsepower and you by doubling the boost pressure, guess what you do to the fuel supply and the injector size? Guess what? You pretty much double it. It's not quite that simple, but that's a really good rough guide, okay? And it's a really good starting point. This is actually a really simple topic, but it's also at the same time really, really complicated. But if you keep it simple, it can help a lot of people work stuff out. And it also answers the question that you see on the forums a lot, where guys go, I've got a 1UZ and I'm going to run 1 bar of boost, how much power am I going to make? Well, guess what? If you look over the forums, there's lots and lots of guys that have got 1UZs with 1 bar of boost up them, and they make about 500 horsepower. It's like it's magic, but it's just some basic physics. Now, the guys that ported these heads are a super stock engine builder here in New Zealand. They're the guys that are building dirt track cars, NA UZs, 10-to-1 compression, no VVTi, and laying down north of 500 horsepower. Okay. This head package on a UZ for a dirt track car with suitable cams would actually make excessive horsepower naturally aspirated. So that's the sort of levels these guys are talking, who are porting these sort of heads and doing this sort of stuff. These days they pretty much start with VVTIs because they make so much more power to begin with. You know, if you go from 256 to 290 horsepower as your base figure, you can understand why when you start adding multiplication factors to that voila, we make a lot more power a lot quicker. In the meantime, I will be doing some more porting of heads videos coming up, so look out for them. I'm going to pull some heads apart myself, get in with my diagram, and we'll do a little bit more showing the low-hanging fruit and where people can get some power out of them without getting too carried away and without making some serious stuff-ups, because sometimes less is more. So I hope that's been helpful. We'll talk to you again soon. Catch you later.